Okay, now we consider the Comet 3i Atlas and the rumor that I had, which was about finding Fibonacci and prime numbers in the outputs that they've been getting from observing it. And to be honest, I went through it online. Um, First of all, I thought it was a hoax, but as with everything, there's a trivial solution to everything. Not everything has just one solution. So if the Fibonacci is a natural number, so it will be naturally have that property, and so are prime numbers. So in the data they got, a nice website to go to that I found after hours of research. I don't know what's available to the public, but if I can find it, it's available to the public because I don't look in restricted areas. So whatever I found, somebody can go online and find. It's right there. So I was looking at the photometry data, and this site arxiv.org is quite good. There's quite a few scientists on there, very good scientists. I'll have a quick look at them. Yeah. So they had just to get on with it. They were looking at bandwidth, where you're looking at bandwidth normally refers to the wavelengths of different frequencies of light, like red, blue, and so forth. If I could just give you a quick explanation of it. So basically, you've got the bandwidth of all these like visible light. Yeah, you got blue, green, red. You must have heard of RGB, and I've heard of that. V. These are the different wavelengths that they've got, and so this site, they were give a second. They were using bandwidths in a in a robotic atlas network. Yeah, they had one they call C, which is 420 to 650, O, which is 560 to 820, and Tidy, which is 420 to 720. COW, which is cow. Yeah. So they had a nice cow there. Yeah. So I won't go through it. You can go to the website and look at it. But they got observation data. So I'm giving you this talk based on observation data that's been done by quite a few good scientists. So the observation stations are there, and the data when they're observing 3i Atlas look like that. I won't go through it because I got my own talk. I got my own theory. Yeah. So they got that data there. Yeah. So I took that data. Yeah, from their site. So I'm not making things up. Yeah. And I tried to answer that question where people were saying that there's Fibonacci on it. So I did my own Excel spreadsheet. So that's their data, as you can see. I took out the bits that I wanted. So I thought to myself, how would you prove that? Yeah, so you get the timestamp. Yeah, for example. Then I used a linear progression. Yeah, or regression. So basically, what that means, what they were observing. Yeah, and I took the total time that was available to me, which was from March to August, in that paper. March to August, we're in January now. We're talking about 2025 here. So I took that data from when they started, from when they finished that set of results, and then I said, okay, I took a linear average, a linear gradient, yeah, or negative gradient, because it would be losing luminosity. I think it was gaining at that time, wasn't it? It was basically changing color, like from the bandwidth result was just changing. So I think it turned more red as it got closer to the sun anyway. So it's becoming less and less red. You can read it up on that paper that I just put up a minute ago. Yeah. Right. So let's see. So I took those results, and obviously I got they were giving us the uh, serial numbers of them. Yeah, so I took the gradient that I had developed. Yeah, and I said, right, after this many days, it should have changed by this much. Yeah. So if it didn't change by that much, then it's deviated from what it was supposed to change. I know they use different gradients, but I used the linear one just to start off with. Yeah. So on my gradient, yeah, um, and this is how I calculated it. I found that there was some Fibonacci numbers showing, and some primes as well. Yeah, yeah. For this C, you know that cow, COW. I separated them, but they mixed up their results. But I separated them, so I just concentrated on C's, O's, and W's. Yeah. So for the C's, there was quite a few Fibonacci there, and the dates when they were taken, you can see there on the screen. Yeah, you have 30th for March all the way up to July. Yeah, I know they discovered it on the 1st of July, but they might have cited it beforehand when they were backtracking. Yeah, so if you look at the graph for it, yeah, um, there was some hits, Fibonacci and primes. Yeah, so it was doing that. So at the time, my meditation was based on Fibonacci and primes at that time. Yeah, so and I kept sensing things as I was doing it. So I don't know. Maybe maybe there was some kind of resonance there. I don't know. Yeah. So the other one, O, yeah, O was there was quite a few hits. Yeah, where Fibonacci is in blue and primes are in red. There was quite a few hits, quite a few. Yeah. So that has proven that they are Fibonacci numbers hidden in the data set. I'm using the data set from what we observed, yeah, from the intensities that we observed, yeah, the bandwidths that we observed. And if you look at where they were supposed to be and how they deviated upon that, the absolute values, some of them deviated in a negative way, but the absolute values, yeah, how they deviated, and I got the absolute values and I multiplied them by 100 just to get whole numbers. Yeah. So how they deviated, you can find prime numbers on there. Yeah. So it's quite interesting to know that, like the type of prime numbers that we're finding actually, where majority, um, that's the deviation multiplied by 100. Majority, there was 21. 21 came up quite a lot. Yeah. It never went higher than 21. So from 1 to 21, the Fibonacci numbers are 1, 1, 2, 3, 5, 8, 13, 21. Yeah, so that's 1, 1, 2, 3, 8, 13, 21. Those are seven, the first seven Fibonacci numbers, yeah, or six. Yeah. So, and my meditation was not going up to that much. It was just basically coincidentally finding Fibonacci here and there. So I can't see any other obvious pattern unless you can see it from the graph of that table for O. Yeah. Um, you can work out something from there anyway. I couldn't be bothered. Yeah, and that's the one for W. Yeah, they only had one, and it was a prime obviously for both. Yeah, a prime and Fibonacci as well. Yeah, but you can see the dates. Yeah, um, yeah, I put it clear on C, but on O, the dates will correspond to here. Yeah, to here. We are converted their serial number into a date that I can understand, and a timestamp. Yeah, so yeah. So um, this also helps me with my theory. You know, like the primes and the Fibonacci numbers are natural to us, and when we're meditating, yeah, we kind of, when we come across these numbers, yeah, let's say you've been meditating for 1 minute, then you've been meditating for 2 minutes, for 3 minutes. Whenever you reach a Fibonacci number, right, your meditation experiences something. That's what I noticed. Yeah. So when I started noting it down, I noticed some Fibonacci as well. Yeah. So um, as a chosen one, obviously the sensitivities that we have, we also have to think that these are natural phenomena. You know, the way we're sensitive must follow a natural pattern. You know, so I always look out for those kind of numbers. That's why I was so interested in Fibonacci and primes. But definitely, you have proven that that did happen. You know, for that period from March to August, the data they were collecting from the intensity they were measuring, you could see Fibonacci and prime numbers in there. It's a stretch though. It's anecdotal. It's a truth that's kind of irrelevant. I can't see anything meaningful other than the fact that there was that many prime numbers and Fibonacci involved in that. Yeah. So that's all I wanted to add. Yeah. Just bear in mind